Hello everyone, welcome to the AI practical series. In this particular session, we will study about the decision tree learning. So, I have divided this particular session into two parts. The first part is explanation of the decision tree learning, and the second part is the Python implementation, execution, and explanation of the code. So, first of all, what is decision learning tree is? So, a decision tree is a supervised machine learning algorithm which can be used for classification as well as regression. So as we have seen in the previous sessions in the KNN, it is also supervised. This is also supervised learning. So in supervised learning, we have some training sets and then we test them. So it is a tree-like model which make decisions based on a series of conditions which can be true or false. And we have various nodes. So each internal node in the tree, it represents a decision rule which can be based on a feature. And finally, if we have each leaf node, finally where there is no expansion is possible, then it represents a class label or a predicted value. Now this is an example of a decision tree learning. Like suppose if we have some fruits, various fruits, then the first classification we can do in this case is whether the size is greater than 10 centimeter. If it is true, it comes to this part. So here it asks whether the color is green or not. If it is true, then it is watermelon. If it is not, it is a pumpkin. And here if it had been false with respect to the size, then it will ask whether the color is red or not. If it is true, it is apple. If it is not, it is a mango. So this is a simple example. So we can make such trees extending to various branches. So this is the required Python code for implementing decision tree learning. So here we use NumPy, pandas, and matplot for plotting the graphs, and then this sklearn tree as well as skmodel and skmatrix. So this part, this data pd.read.csv, it reads the data. So we are using the iris data set. I will give the link in the description section. We can download from there. It is also available on net. So in my case, because I have downloaded the data and I am using Google Colab for executing the code, so I have to upload that particular CSV file. So this is what I have to do, iris.csv. But in case if we are running on Python IDE, then we have to give the entire path of this file. We have to save this file in our system and then give this particular path. And one more thing here, when we download the iris set directly from the website, then this I have written here target, but when in that particular data set, it is mentioned as species. So because in our case it is target, so we have to make the changes in that rightmost column. So there are 5 columns. The rightmost is the species. I have written a target, so I have to rename that particular as a target. Then here we have the I'll explain this code afterwards. So finally what we get is we get the accuracy answer, and then we have the various plots. So let us now execute this code on Google Colab, and then I will explain this code line by line. So now to execute the code, we are now in the Google Colab. I'll just click on the code. I have copied the code. I'll just paste this code here, and then we will execute it. So this is the required code. Now before executing this code, we must actually upload the data sets. So I'll just click here, and here I click here and give the path. So in my case, my this file CSV file is this iris CSV. It is in my this particular folder. I'll just open it up, and this is the file. Okay. Now when we are doing this in Python IDE, then we have to give the path of that particular file, whether it is in C drive or D drive, whether. So this is done. Now we'll just execute the code. I'll just click it here. So now the code is executed. So this is what we are getting. Accuracy is 1.00, the best possible thing. And here we get this particular iris data set. This is the data tree visualization. Okay, this is what we get. This is the output. Okay. This is due to the which we are using this matplot library. So it plots this, it gives this plot. It makes the decision tree. As you can see, the arrow is there, so it is pointing this way or this way. Then again we are getting this way or this way. So it is actually classifying, making the classes iris, setosa, Iris versicolor, okay, and Iris virginica. So this is how this particular code executes. Now I'll explain the code.
These lines import the necessary libraries and modules that will be used in the code. NumPy and pandas are used for data manipulation. Matplotlib_pyplot is used for plotting the decision tree. Decision tree classifier is the class from scikit-learn used for creating a decision tree classifier. Train test split is used to split the dataset into training and testing sets. Accuracy score is used to calculate the accuracy of the model. This line loads the iris dataset from a CSV file named iris.csv. In case if the file is stored in the systems, then we must replace iris.csv with the actual path to the iris dataset file. These lines split the dataset into features X and the target variable Y. X contains all the columns except the target variable, which is assumed to be in a column named target. Y contains the target variable, which is assumed to be in a column named target. This line splits the dataset into a training set xtrain, ytrain, and a testing set xtest, ytest using the train test split function. The test size parameter specifies the proportion of the dataset to include in the testing set, in this case 20%. Random state is set for reproducibility. This line creates an instance of the decision tree classifier CLF from scikit-learn's decision tree classifier class. This line fits trains the decision tree classifier CLF to the training data xtrain, ytrain. This line uses the trained decision tree classifier to make predictions on the test data and stores the predictions in ypred. These lines calculate the accuracy of the model by comparing the predicted labels ypred to the actual labels ytest and print the accuracy score. These lines create a graphical visualization of the generated decision tree. PLT figure sets the size of the plot. Plot tree is used to plot the decision tree, with options for filling the tree nodes with color, specifying feature names, and specifying class names. PLT title sets the title of the plot. PLT show displays the plot. This code essentially loads the iris dataset, trains a decision tree classifier on it, evaluates its accuracy, and visualizes the decision tree structure. That's all for this session. Thanks for watching. Like, share, subscribe and comment.